Today's lesson is about the mean value theorem. As you see on the screen, there are three xy coordinate plane shown. In each one, I'm going to connect A to B. In the first one, the red one, I'm going to connect A to B with two conditions. First, function must be continuous, and secondly, differentiable. It could be the case, so I connected A to B. In the second one, in the blue one, I'm going to connect A to B. However, I want function not to be continuous. For example, it could be like goes up like this and then goes like that. So I've connected A to B. However, function is not continuous. In the third one, the green one, I want function to be continuous but not differentiable. So it could be like that. As you see at this point, let's say C, function is not differentiable because it's a sharp point. And we explained actually already that at the corners or sharp points, derivative does not exist because the derivative is the ability of drawing tangent line, but tangent line at C does not exist, or it's not unique. Okay, so now also I'm going to connect A to B with a straight line. So also I'm going to connect it here with a straight line. In the third shape, I will do the same. The question is, in which curve there is a point or points that if you draw the tangent line is parallel to the straight line that connects A to B. I believe we can find a point on this graph here, for example, that if you draw the tangent line is the red line, which is parallel to the straight line that connects A to B. But in the second and third shape, you cannot find such point that if you draw the tangent line would be parallel to the secant line AB. So therefore, we can say that if f is continuous and differentiable, it is curvical, then there exists a tangent line parallel to the straight line. So there exists a tangent line parallel to the secant line. Or segment AB. So this existence of a point on the curve that the tangent line is parallel to AB is known as the mean value theorem. So far we've learned that if function is continuous and differentiable, and no matter how you connect A to B, in this case, in this graph, I believe there are 2 points on the graph, on the curve, that tangent line is parallel to straight line between A and B. I think one of them is here and the other one is here. So we will not forget the conditions. The conditions are very important, and sometimes AP questions are all about the conditions. So the conditions are continuity and differentiable functions. So now we need to change what we said about the mean value theorem with words to math format. So assume that the x value of this point is C, the x value at A is lowercase a, and at B is B. Obviously, the y value at A would be f of A. Also, the y value at B is f of B. So we claimed that the little red lines that I've shown here are parallel to line segment AB. Therefore, these slopes are exactly the same. How do I get the slope of these red lines? Obviously, this is f prime at C, because we know derivative gives us slope. And what is the slope of straight line between A and B? So slope of AB is delta y over delta x, according to what we learned in grade 10. So delta y means difference between the y values. The y values you can see here. So it's going to be f of b minus f of a over b minus a. Since the red lines and the blue one are parallel, they have the same slope. Therefore, there exists a c that f prime c equals f of b minus f of a over b minus a. And c has to be between a and b. This is known as the mean value theorem, and this is the formula of the mean value theorem. Let's have an example. So we are going to find the C satisfying the mean value theorem when our function is f of x equals x squared plus x plus 2, and the interval is -1 to 3. So obviously this one is A and this one is B. So I'm going to write the formula of mean value theorem. So f prime c, so we need the derivative, therefore I'm going to take the derivative here. So it becomes 2x plus 1. So therefore f prime at c is 2c plus 1 equals f of 3 minus f of -1 over 3 minus -1. So 2c plus 1 equals, so f of 3 is going to be 9 plus 3 plus 2 minus f of -1 is 1 minus 1 plus 2 over 4. Therefore 2c plus 1 equals 9 plus 3, 12/4. Therefore, 2c equals 2 and c equals 1. Since 1 is in between -1 and 3, we accept that value of c.